Hello there, and welcome to Retinet. This is a project that aims to classify fundus images into whether or not the patient has diabetic retinopathy. So it classifies based on these 5 categories, from 0 being no diabetic retinopathy and 4 being proliferative severe diabetic retinopathy. So we got the training data to train this complicated convolutional neural network from a Kaggle contest to detect diabetic retinopathy. The competition is over, but the training data is still available. So after we've done that, we just put it up on GitHub. It's open source. So you can download this to classify your own images. I'll show you how you can do that. First, download the zip or just clone it using Git, and then have a copy of it in your home directory. So I have mine here. It's called Retinet. And open the test directory. So once you did that, you can see that it's empty right now. So we will get some fundus images. Let's see. This is a typical case of proliferative diabetic retinopathy. This too. So I have some other images here. Normal. That's a variety of images. So notice that the name of the image should be a number followed by the left and then the number followed by the right as 2 separate images. This is so that the network can differentiate artifacts from microaneurysms. Microaneurysms are pretty important in detecting early stages of diabetic retinopathy. So make sure you give the test folder both the left and the right images. So I'll just copy all this into the test directory. After doing that, open a terminal and then change your directory to Retinet. And then I have a script called predict.sh. So just run that script. It'll do all that's necessary. So what this does is it first converts the images in test into a resized image that is smaller, because the neural net can only handle 512 by 512 images. So it's converting right now. So after it did that, it opens IPython notebook. So in this, you need to have a graphics card, and I'm running on Linux right now, and this is kind of designed for Linux. So you need to have Theano and CUDNN installed. Make sure you have CUDA and a graphics card, obviously. So after you open this notebook, just restart and run all. Now let's see what our network predicts. Still running. Yeah. So we have our result, and wow, this 4 is proliferative diabetic retinopathy, and it got it right. And you see, this is the probability scale, and this is the classes scale. So 4 being proliferative diabetic retinopathy, and this is almost 100% sure that it's proliferative diabetic retinopathy. So let's see the next one. Okay, yeah, this looks like severe diabetic retinopathy, and it did classify it as severe diabetic retinopathy, but it kind of has a doubt whether or not it's severe. It's almost 50-50 between moderate and severe, but that can be excused because the lighting conditions aren't that great as well. So the next one, this is moderate diabetic retinopathy, and I think it got it right as well. I think it's labeled moderate. So this is normal, yeah. No signs of microaneurysms, so that's normal. This too, this is normal, and notice that there is an artifact here, but then that is an artifact, and it still says it's normal because it is. And in the end, this is normal too. So in this test scenario, it got all of it right. That's 100% accuracy rating. But then it doesn't give all of it right most of the time. It has a confusion between 2 and 3 in classifying whether it's moderate or severe. So beware of that. But otherwise, it's a really great network that can classify whether or not a patient has diabetic retinopathy in early stages, and this can be used for screening in a very short span of time. Thank you.